Hi, so in this video content I will introduce you with the regression example for machine learning with Jatson Nano board. First we create our data structure, then we feed our model. With this data, finally you will see all process with an animation that makes you understand better the whole process which is done by the TensorFlow. Regression example is really good point to start the machine learning. We will just create some random data and then try to estimate the best fit or the best linear equation for this data set simply. Linear equation is used in regression example. W is called the weight and B is bias, which is an intersection with y-axis, as you know. The aim is to find best W and B values according to changing the X and Y from the dataset. This is the point. This equation actually, this linear equation, can be seen from TensorFlow like a graph data structure. So we will create a graph data structure with the TensorFlow library. Then we will feed these data to train our model that we will create to find the best fit equation. So TensorFlow handle the graph data structure. We will find more complex data structure in the next tutorials, maybe like a human brain. With the TensorFlow we can handle these situations, this process. So let's start. Open a terminal. I will open also another terminal here. This terminal is used for the command line. I will test some lines of code. Let's import TensorFlow. As you see, there's no problem. It's imported right now. Before going to the code part, let's check which device we can use, actually which GPU is used by the TensorFlow. We can check with this command, config Prato log device. Then as you see, GPU 0 is used and Tegra X1, or you can find more information there with this command. So I used the Vim for as an editor actually. Let's import the NumPy. NumPy is used our mathematical operations, Panda for datas, Matplot for plotting the things, and finally I just import TensorFlow. So first we create a dataset with this simple NumPy line space. It will create between 0 and 10 and divides 1 million apart. Let's see in the command line how a line space works. So as you see, it divides 0 to 10, 10 as a 9 part, right? There are 9 values. We just create 1 million values between 0 and 10. And let's create our equation that we just try to find out in the next. And also I add some noise, which is an NumPy random round n with ln x. It will add some noise, that is all. I will just I will draw the set of data, don't worry, you will understand better. And I just create a data frame, and also for x and also for y. So let's check here. What are they doing? As you see, it's just a data structure. That's just a set of data. So we collect X data and Y data, X data frame and Y data frame into the one part as I collect data. So now let's print all the data there. I just sampled 300 of them. I couldn't actually plot the 1 million data. It will match. So I just plot a scatter. X will be X and Y will be Y. And the plot show. Let's quit from the command line. And let's run the example. Python 3 linear regression Python. So it will take some time. There is an error. As you see, random data is created. So we just try to find out or predict the best fit for this set of data. So the next step, creating a model. Model means the training actually. We just train this model to find the best fit for our random data. I create the m, which is a slope, as a random numbers. You just give whatever you want. I just give 0.21. If you put there 0.7, that you will directly find solve the problem. Actually, this is wrong. You will be cheating. That is why I just give 0.21 and 0.71. So I create the placeholders. Placeholders I use to change the grep data. These are really popular in the TensorFlow. As you see, I didn't assign anything this X placeholder and Y placeholder. During the training, we will change this data. So I create the model equation, TensorFlow adding and multiplying. Model equation can be also represented to the right side. M multiply X placeholder plus B. So the next one is the train model. We will first optimize our model with a learning rate, and then minimize the loss function. Loss function is difference between the real output and the calculated output. This is important. Loss function is the difference between actual and real output and the predicted from the model. So there is a problem. Let's run. Yeah. Here, this will be comma, right? Not the star. So there's no problem. We will initialize the global variables. Then we just create the training right now. We have to initialize the global variables from the TensorFlow. And now we are creating a session. In this session, we train our model to find the best fit, as I told you before. I just run the init. Then as a first time, I just give a train step 10. That means it take the 10 set of data from our random set that try to find the best fit, but this will not work, as you understand, because there's a 1 million, right? So just feed our train model from the placeholders. Placeholders is used to this. Then we will get the result M and result B, which are actually the real result for the equation. Then we will simply calculate the result Y, which is an equation. As you see, result M, X plus result B. Then we will just plot the result right now. Forget the show. As you see that fitting is not correct because we just take the 10 value, right? Just increase the 100. Just make it 100 and we will see a better result, but not the correct one. See, this is better, but not the correct. So let's increase 10,000. It will take more time. I stop the video and I start again. And here's the result. This one is better. See, the equation, the line is fitted our data set. But this takes more time. So now we create a step size. Each training step, we get 10 value. This will make our system, our training faster. So to do that, we will get random value from our dataset. Okay. And we feed 10 value to our train model. with a step size. We have to care about the tab. We are using Vim, right? Here we put just an index and there will index. Now we can remove 1 0. This will be much more faster. As you see, this is much more faster, but also the result is good. It's fitted, right? So how we can see right now dynamically this process to understand better. We can see that dynamically we can animate the whole process with PLT-GCA, and we create axis with an X limit which will be 0 and 10. You can give whatever you want here. And for the Y limit, I will just give here and 0 and 20, let's say. So I just create a line for plotting X data frame and a Y data frame as you expect. So red. So now we calculate the result and result B in the for loop for each process to draw the line. Drawing the whole animation also takes some time, we will see. Also, we create the result Y, the equation. Then we are set X data here for X, and also for Y, we set the data from the result Y. And we draw it in the for loop. Just give some number to pause. Let's run. As you see, now regression is animated here. Now you see the y-axis is going up to find out the best place to fit our data set. Normally video is faster than the normal speed. Normally it will take more time. So I will leave you with this animation a few minutes. So guys, as you see, it is about to finish. The code example you can find in the link below the video. That is all for me for this video. I really like to watch this regression in animation, in an animated way. So, thanks for watching, and don't forget to subscribe, and see you around.